This is for class 12. I have written the important points here so that it will be better for me to explain it. So it is a result of Ampere's Maxwell law. That is cyclic integral of B dl, magnetic field into dl, mu naught I plus here this mu naught epsilon naught d phi E by dt. Here this is the important result which Maxwell got. That is the displacement current due to the change in the electric field. This is the displacement current due to the change in the electric field. So what are the important results of Ampere-Maxwell law? This displacement current, this is a very important point here. That is now the results. Displacement current has the same physical effect as the conduction current. Means conduction current, the current which is flowing through a wire, that current we call the conduction current. And here the displacement current is produced due to the change in the electric field, which happens inside a capacitor, So inside a capacitor, there is both conduction current as well as displacement current. So here you see the displacement current and the conduction current, they have the same physical effect. That means the current flowing through a wire and the current which is produced due to the change in the electric field, they are the same. Now the second point is steady electric field in a conducting wire. If there is a steady electric field, means there is no change in electric field, it is steady electric field, then there will be no displacement current because there is no change in the current with respect to time. The third point, charging capacitor has both conduction and displacement current present in the same region of the space. Same region of the space means here. This region, they are telling about this region between the two parallel plates. So this is very important. Now Maxwell, it has clarified it that the current flowing through a capacitor has both conduction as well as displacement current. So the current flowing, so if this, because of this, the circuit gets completed. Because of this, the circuit gets completed. So the third point, this is very important, that is charging capacitor has both conduction and displacement current placed present in the same region of the space. And the fourth point is that the displacement current gives rise to a magnetic field. So this displacement current, it gives rise to a magnetic field. So here this is a picture, here you see this is a parallel plate capacitor. Here this is plus charge and this is minus charge, and a current wire is connected here. So now the current is flowing through it. So a cross section, this is the cross sectional view. If you take this dotted line, along this dotted line, if you take the cross sectional view, you will get a circle, this like a circle. This dotted line and this dotted line same. Now yes, you see, you have taken this from the parallel plate capacitors. Here you see that is like this. There are two parallel plates. Imagine here that there are two parallel plates, and you are taking the cross section here, this side. This is the cross section. This is the cross section. Electric field is moving like this from positive to negative direction. Electric fields are moving from positive to negative direction. So if you take this cross section, the electric field will be into the plane of this cross section, So it is represented by cross, it is represented by cross. And the conduction current, that is the conduction current. Here this is the conduction current, and around this we know that a magnetic field is produced. This around this is the magnetic field, and the direction is given by the tangents. At any point the direction is given by the tangents. So here you see that the displacement current gives rise to a magnetic field, and the fifth point is that induced EMF is equal to d phi by dt. This is Faraday's law. That is, when there is change in magnetic field, an induced EMF is produced. If induced EMF is produced, that means there is an electric field. So this is Faraday's law, that induced EMF is equal to d phi by dt, because there is when there is change in magnetic field, there is induced EMF. And existence of this EMF proves that the existence of electric field. It is clear, because if the induced EMF is produced, that means there is an electric field. And again, that is, what is the conclusion? That is, change in magnetic field. That is, change in magnetic field gives rise to an electric field. If there is a change in magnetic field, it gives rise to an electric field. Again you see, change in electric field, this is change in electric field, this will be change in electric field will give rise to an, this will give rise to an, here you see that the change in electric field will give rise to a magnetic field. It will give rise to a magnetic field. It will give rise to a magnetic field. So here, change in electric field will give rise to a magnetic field. That means the displacement current. The displacement current, this displacement current, this is because of the change in electric field, and it is giving up magnetic field. So this consequence of this symmetry, what symmetry means? Change in magnetic field gives electric field, change in electric field gives magnetic field. This consequence of this symmetry is the existence of electromagnetic waves. Because of this, that is the most important result, that is, change in magnetic field will give rise to an electric field, and change in electric field will give rise to a magnetic field. Change in electric field, that is the displacement current. Because here it has been told that a displacement current gives rise to a magnetic field. So this is the this is the existence of electromagnetic waves. And according to Maxwell's theory, the accelerated charges radiate electromagnetic waves. So here, in a summary in your book, it has been clearly explained to you how an electromagnetic wave is produced, and at the same time the most important thing here, it has been explained that change in electric field produces displacement, change in electric field, that is displacement current, and it exists inside a capacitor. It exists inside a capacitor, and the physical significance of this displacement current and the conduction current, they are the same. So now it is clear to you that when a circuit is connected with a capacitor, there is a confusion among the students when there is no conductor, how current will flow through it. But Maxwell, he has proved it, that in the region between these plates, there are two types of current. One is the conduction current and the displacement current. And because of this, the current flows through the capacitor and the circuits get completed. And at the same time, the symmetry, consequence of the symmetries, what is the symmetry? That is, change in magnetic field gives an electric field, and the change in electric field gives an magnetic field. This symmetry gives the existence of electromagnetic waves. So this is all about you, and why? So I have written it in point wise. And this has been clearly explained in your textbook. Thank you.